Stanford University.
3, 2, 1.
It's little known that football, although you hear about it all the time in the media, is not the #1 cause of sports and activity-related concussion. It's bicycling.
We compared the performance of a traditional bicycle helmet, which is made of expanded polystyrene foam, to this newly developed product called airbag helmets.
We found that the airbag has the potential to reduce the acceleration of impact by a factor of 5. This is possible because an airbag that might expand over one's head can be much bigger. And because it's larger, it can also be softer.
The federal test imposed by Consumer Product Safety Commission is at a 2.2 meter height. So we tested from 0.6 meters up to 2 meters. So linear acceleration is traditionally associated with severe burn injury risks and skull fracture risks. Although their linear acceleration is not directly related to concussion risks, we believe that a big improvement in the linear accelerations will also be reflected in the rotational accelerations.
It's important to point out the limitations that if we had tested, for example, at larger heights, you might see things in airbag helmets that wouldn't occur in foam. Because the air is so soft and continues to compress relatively constantly during an impact, will it ever bottom out? If our research and those of others begins to provide more and more evidence that this airbag approach might be significantly more effective, there will be some major challenges in the US to legally have a device available to the public.
For example, federal standards do not test for triggering, which is essential for this product because it needs to be triggered and expanded around your head to actually make it work.
Whether it be a foam helmet or an airbag helmet, I think we need to look a little bit more comprehensively at the federal test standard and at safety.
For more, please visit us at stanford.edu.